we can just open that report and have a look. Yeah. So, yeah, as the Gartner report says, the number 4 trend is digital twins in 2019. So it says that a digital twin is a digital presentation that mirrors a real life object, processes or system. Digital twins can also be linked to create twins of larger systems such as power plant or city. So this is what we can say smart cities is achievable by digital twins and BIM technologies. So the idea of a digital twin is not new. It goes back to computer-aided design representations of things or online profiles of customers. But today, digital twins are different in 4 ways. So I will focus on the second one. So because we're mostly concerned of this one, it's about the linking to the real world, potentially in real time, monitoring and control. So we are linking our virtual BIM model to the real world to take real-time data, to monitor the equipments and so on. So this is very important for our implementations of project management. This is why we have to mention that. Okay, so we will have some information on Istanbul Airport. We have 4 phases. So you are seeing the master plan right now. Being the world's largest airport project, the project scope consists of 4 phases. We have finished 1A right now, which includes a terminal building, 2 runways, supporting facilities, TC tower, air traffic control tower, fuel farm, and cargo. So, and Terminal 1 building includes an open car which facilitates 700,000 meters square and more than 50,000 car capacity. And as I said, the first phase includes 3 runways, which we have completed the construction of 2 runways. The third one is under construction right now. And the late phases includes 1 satellite terminal and 3 more runways. The total project area consists of 76 million meters square, where we will have 200 million passengers per year. Also, 350 destinations all the world will be operating from it. So Istanbul Airport will be the very major hub that connects the entire world. So let's look at the project timeline. It's very interesting because the construction size is very huge. So there is a tremendous amount of coordination has been held, and a huge amount of effort has been held because there were a very, very tight schedule, 42 months of construction period. For this size airport is very, very tight schedule. One term of this size of airport have multiple, twice or maybe triple of to be constructed. So we end of this construction period right now. Right now the airport operation is started. We are in the 25 years of operational period right now. So, looking at the economic impacts we have by 2025, airport will be facilitating 225,000 employers. So, huge amount of value will be added that we can say nearly $40 billion. The project budget is also 22.2 billion euros, plus the taxes to government, which will be paid over yearly, over a 25-year period. So this is a very high budget. So in here, you can see the comparison with the known airports and the old airport in Istanbul, which is Istanbul Atatürk Airport. So you can see the concession lines, boundaries, the purple lines. Istanbul Airport have this master plan boundaries, and you can see that Beijing Capital, London Heathrow, and Hartsfield Jackson Atlanta, and compared to their passenger capacity, Istanbul Airport is one of the world's largest one. Also, having the largest airport, we have had a very tough transfer operations, because we had to transfer an entire airport from one airport to another, and this has been planned before 18 months before the opening day. In terms of operational readiness, we call it ORAT, so operational readiness and airport transfer. BIM is fully used for enhanced reporting and execution of the operational readiness and airport transfer plan. So the preparations of the airport transfer was, as I said, started 18 months earlier, including the commissioning phase. Transfer from the Atatürk Airport was planned to be done in 45 hours, but we have completed it in only 36 hours without any major issue, actually. And full operations were started on day one without any problem. It was the 7th of April 2019. So this shows one of the enhanced reports that we use BIM models for operational readiness and transfers. We use mainly Autodesk tools, BIM 360 for site reporting, and Navisworks and Revit for the collaboration and coordination. This is one of our ORAT phase reports. I have to mention that. So our team has also prepared an airport transfer simulation with InfraWorks that calculated the best routings for transfer trucks, low beds, and other aviation equipments. And determining the parking positions was very important. So more than 1,800 trucks delivered equipments during the process. So this was a huge transfer, I can say. So the traffic were also included in the calculations, and all the trucks when they are leaving the starting point and when they are arriving the destination point, all of them was integrated in the InfraWorks, and we had this simulation to further enhance the transfer process. Yeah, so we can now start how we implemented BIM in this huge project. This is the basic BIM project lifecycle you mostly are familiar with. In my opinion, this is the first important step with the successful BIM project lifecycle is utilizing and maintaining the correct design and clash-free, carefully engineered design. And the second important step is to deliver this correct design to site on time and let the right people reach the information without any restrictions. So if you don't have the correct product, then it is nonsensical to even try to plan and deliver it to the construction. So it is very hard to finish the project on time and on budget, actually. And lastly, we are moving forward to the facility management with BIM-based. And we are having the huge benefit of implementing BIM for all of the phases in the project. which we will be talking about. So to fully integrate BIM for our project, the strategy was collaborating and coordinating all the parties, all the disciplines, including mechanical, electrical, structural, special airport systems, infrastructural systems, ICT, architectural and structural. During the project lifecycle, we have created our modeling strategy in a developing manner to match with the very tight construction schedule. So at the beginning, you just cannot do everything at once. So we have started from the base and we have constructed it until the operational phase, which you can see in here. We have started with LOD 200, 300, and we are now at LOD 500 as a development level of BIM. So in the beginning of 2016, our BIM management building was utilized and the execution plan was already ready before the construction starts. This is so important because you have to plan and organize your BIM team and your equipment, your technology infrastructure, even before the starting of the construction phase. Actually, what we have in this project is having the parallel design and construction. So we didn't have the design period before the construction. Design and construction effort was parallel at the same time. So this is why we had a very tough period of construction. So you can see at the right hand side the BIM execution plan, which have been distributed to all the subcontractors, all the parties, internal and internationally. Talking about the BIM and BIM implementation, we have to mention that this is very important to apply good governance on successful project management. So these simple notions are very, very essential for successful project delivery and at the core of applying good governance in your team and even in your company. So if only one of them is absent, then you will likely to have struggle at some point. Let's look at them shortly. So consistency, responsibility, accountability, fairness, transparency, effectiveness, and deployment. So if you are doing the good governance in entire project, so you are likely to be successful. So one of the core necessities for BIM implementations is applying and understanding the importance of good governance, actually. So in general, I can say that there are challenges when implementing BIM. So this is a general case. So especially in developing countries, especially in Turkey, challenges against implementing BIM can be told as overcoming the resistance to change and getting people to understand the potential and the value of BIM over the conventional project coordination, and adapting existing workflows to lean and oriented processes. Also training people in BIM or finding employees who understand BIM. The understanding of the required high-end hardware resources, IT and technological infrastructure. The required collaboration, integration, and interoperability between the structural and the MEP designers and engineers. Clear understanding of the responsibilities of different stakeholders in the new processes by construction lawyers and insurers. So these aspects are the main concerns that we face in a project to implement BIM. They are the main challenges that we face. We have also faced in this project with some of these items, but we have overcome and successfully delivered the project, and we will see how we did that in later slides. Now we can look at design and engineering coordination phase. So this is our systematic graphic for the integration for entire project that connects all the systems and parties. BIM models are at the core of all workflows, including the design, engineering, and coordination. All design and engineering processes are handled with BIM-based approach in here. So it has handled in virtual environment, including digital engineering, clash-free coordination, and digital fabrication. At the core, our aim was having the correct design, and after achieving that, it was the correct time to deliver clash-free coordinated models to site, and we call it mobile BIM. So this is not a new term actually. This is now worldwide used, and the iPads, tablets, mobile is very familiar. So, but in that time, we have started this project, especially in Turkey. It was not actually done in any of other projects in this huge amount of coordination. So our mobile BIM journey has started after utilizing BIM site team, who handles site engineering, quality control, test and commissioning processes on site. And actually, we can say that site engineering includes site supervision and project control, which Tolga will be talking in detail. At the left-hand side, you can see our BIM room, where we had all the international and internal meetings, daily and weekly meetings. Full BIM implementation actually is achievable only with a logically structured and tight schedule. Without any tight schedule or a very strict tracking of the works, you cannot actually achieve the successful BIM implementation. Again, you can see at the right-hand side our weekly workshop schedule. We were in contact with the entire world. We had subcontractors in UK, in Holland, in Singapore, in India. We were talking to them and solving the issues, problematic issues, and engineering with them in this room. You can briefly see the systems that we have integrated in our BIM model. This is our scope of the BIM model, including, as I said, all the MEP, IT, and infrastructural and architectural and structural items. We have implemented all the systems into the model. When we are talking about the BIM scope, we can say that we have implemented a total area of construction area of more than 2 million meters square of facilities, including terminal, 5 piers, car park, utility center, and ATC tower. The rest of the facilities, including supporting buildings, which we can say 170 supporting buildings, were modeled very in low detail, LOD 100. And also, Turkish Airlines buildings were modeled and integrated into the model. Also, from the infrastructure perspective, runways, taxiways, upper and surface models are also integrated. Modeling, clash analysis, and across coordination of infrastructure network in airside and landside areas takes approximately 14 million meters square. This coordination includes APM, air passenger mover line, galleries and tunnels, drainage, electrical network and mechanical systems, irrigation, IT systems, actually all the stuff that is constructed were modeled and coordinated in the BIM model. You can see MEP, IT and special airport systems rendering of terminal building right now. You can see how complex and dense the systems are. Also, we have an animation, a walkthrough inside the BIM model. that you can see the structural slabs and architectural items were hidden in here. You only see the systems above and below. You can see the detail of the modeling effort. So you can see at the below, sorry, excuse me. You can see below the baggage handling system, which consists of the conveyors and the supports of the conveyors. That has been really tough to coordinate every single supporting element. A tremendous amount of coordination effort, we can say. You can also see 5 piers in here, also MEP IT systems isolated. This is the car park model. This is the utility center model, which connects directly to the terminal building with a gallery. Consists of mechanical and electrical equipments. This is the ATC tower. You can see the steel structure and the MEP IT systems. Also, as I said, this supporting facilities also modeled in 3D, but used as not coordination purposes, used as planning purposes. We will show some 4D simulations on that. Okay, so I will hand over to Simge. She will talk about construction and commissioning phase.
Thank you, Ahmet. I will present you about how we handled the construction and commissioning phases with BIM. 30,000 Primavera activities have been linked to the BIM model to achieve 4D and 5D BIM integration for scheduling, quantities, and cost estimation. This model was used for weekly executive reporting and was the main discussion point during the executive meetings. You could see by weekly basis where you should be in the specific areas of the construction in all disciplines. During the manufacturing process, also you can see that there are a total of 56 tower cranes that causes a huge amount of gaps in the concrete slab. That's an important issue for work sequences. This is also handled and managed with the help of our 4D model. Also, in here you can see there are 170 supporting facilities. Sorry. There are 170 supporting facilities other than the terminal and car park. They have been tracked according to our 4D BIM models and reported by the executive levels. In here you can see some iPad usage on site. We have facilitated 150 iPads for our site engineers to make design products, including BIM models, shop drawings, quality control, and quality assurance documents. They are easily accessible right on the field, and we have mainly used Autodesk products to utilize mobile BIM. Actually, also Ahmet mentioned, this is common in today's construction works. However, when we first started these works in 2016, it was the first and the biggest mobile BIM implementation and developed with Autodesk tools. We have also received feedbacks from Autodesk managers that our models in the cloud was the biggest in the world. Then let's talk about numbers in terms of BIM execution. More than 45,000 digital checklists and tasks assigned. 792 critical coordination issues resolved on site. And in the later slides, you will see real examples on how we have saved the project with enabling mobile workflows with BIM. Now we will look at more numbers. More than 600,000 digital clashes are reviewed and classified in virtual environments. 240,000 critical clashes issued and solved before projects are delivered to site, which is more important. More than 8,000 shop drawings reviewed and approved by the BIM team in compliance with the BIM model. As mentioned before, 100,000 Primavera activities implemented for the, as mentioned. 150 iPads have been utilized for the engineers to have every model, shop drawings and other documents right in their hands on site. More than 45,000 quality control and commissioning documents were created across iPads. 1,300 issued, resolved and recorded on site by BIM Site Engineers team. More than 1,000 people trained in Navisworks and BIM 360, and this is one of the most important achievements leading to a change in the mindsets and people transformation. 1.2 million A4 page equivalent documents saved from printing, and 3.5 terabyte BIM data on stored in BIM 360. And finally, bigger than 17 gigabyte Navisworks master model in our cloud. In here, you can see BIM 360 dashboard. We can easily track company performances, open and closed issues, and so on. The ease of this system provides us a very powerful reporting and tracking of whatever happening on site. Non-conformities were recorded in the digital environment. Related parties were informed automatically and taken action. Also, I have mentioned that observations are tied to the progress payments of the subcontractors upon their performance. This one is also our weekly reports indicate subcontractor process on issue resolutions. Upon the finishing of the phase 1A, we have more than 700 active BIM 360 members using the system, and also 61 companies are registered to the system with at least one key personnel to manage BIM 360 at their hands. In here, you can see the examples of BIM 360 test reports, and all issues are recorded with photos and comments on site. BIM model is very accurate, but even you have an accurate model, it's inevitable to have defects on site. Site supervision and project controls are also fully managed with BIM 360 by the BIM site team. Very critical issues are resolved before they cause any delays on site. Our site teams has been working with subcontractor, even sometimes to clear all the issues on site. BIM model elements are digital twin of the real equipment on site. Equipment have been tagged during the test and commissioning process for further use in asset and facility management. Now we are also working on the facility management model. I will present you about how we handle the construction and commissioning phases with BIM. In here, we have the approach of developing models depend on what project stage is. First, construction model is developed during the construction phase. Design and coordination, clash detection, shop drawing production and control, sites engineering and supervision, project control, quality control, and room data sheets dependent on our construction model. After that, we have developed commissioning model where we have tagged all the equipments and rooms, quality checked, the entire asset information, modeling of second and third fixed equipments. Finally, we have developed an operational model for facility management purposes. This graphic gives us more detailed insight on the phases of connected BIM strategy. We are at the occupancy and operations stage right now. There are 4 identified phases for BIM 360. First one is creation of commissioning data and development. Second is development of commissioning and operational model. Third is airport system and connected model information. And the last one, completion and handover. This is a very interesting part actually. You can see the mechanical equipment family categories of the entire project, and I will zoom out a bit. This one is the list of the mechanical equipments, and zoom out it again. And this one is the total list. This is our entire tagging and commissioning strategy for the airport systems. The total number of equipments in BIM for all disciplines, more than 4,000. Total number of equipment types, 8,573. Right now, we are dealing with the BIM-centered airport operations, which is including asset management, work request allocation, process automation and analytics, business process development, incident management, third-party integration, facility booking, and enabling user journey. Now, Tolga will present their BIM Site Engineering part.
Thank you, Simge. Hello again. I will talk about the benefits of using BIM in interdisciplinary coordination in the field and why it is necessary. Before we begin, I would like to first mention about the project errors or mention about the manufacturing defects. There are 2 main reasons why the field works are wrong. The first one is project errors, and the second one is human factor. Although there are many reasons for project errors, the most common one is lack of effective communication between project teams. And also, project errors can be evaluated in 3D with BIM. And conflicts can be largely eliminated or prevented by with BIM. And on the other hand, human-made defects occur during construction, and it can be only eliminated, prevented by regular field checks. In this context, IGA-BIM field team was established by IGA-BIM departments to ensure that the field manufacturing is compatible with BIM models and to prevent the human-made defects by regular field checks, through the regular field checks. We have a BIM field team of 8 people, including myself. Each of my engineer friends are responsible for one construction area, and each one is responsible for monitoring the field manufacture according to the BIM model that's located in their iPads. At this point, it is very important to reach every worker in the field and also follow the works from the beginning. Whether you have the best model or use most up-to-date technology, it makes no sense if the BIM model is not used during manufacturing process. On the contrary, it makes vested investment. For this purpose, every engineer friends, my engineer friends check the field manufacture of mechanical, electrical, IT, and also architecture and other disciplines under construction in the construction area, which are responsible, and they all reported the defected issues. We have created two different site reports about the defected defected manufacturers. The first one is BIM site observations, and the second one is BIM site supervisions. BIM site observation reports include field works carried out which are not complying with BIM models and consequently affecting the field manufacture of another disciplines. And BIM site supervision reports were created as a result of the determination of fieldworks that would cause conflicts with other disciplines if the production had just started and continued as it started. So here you can see some of BIM site observation reports that we created. Each issue you can see here belongs to the real conflicts of medium or high importance. Although the time taken for resolution of the issues evaluated within the scope of observation reports varies, the average duration is 1 week. In the lower left corner, you can also see the total number of observation reports generated. It is about 861. And here you can see the generated BIM site supervision reports. The solution time for the issues included in the BIM site supervision reports varies from 1 to 3 days. And again, you can see the total number of issues we created in the level of corner. I will like to show you an example of the field reports we have created for your better understanding. The first you see is a conflict that's recorded in the BIM site observation reports. Here, the dock was completed, but the wall construction could not be completed because the dock is not where it should be. On the right, there is a screenshot from the model. Here you can see where exactly the dock should be as coordinated. And this example, the clash you see here belongs to the BIM site supervision report. The supports, you can see the screen left on the left, belongs to the electrical cable trace. After our site control, we determined that the supports should not be there. When we check the model, we saw a wall here, so we warned site teams. The action took place quickly, and the supports of electrical cable trace were shifted to the left. In the right, you can see the wall construction has begun, and the installation of electrical cable trace is running correctly. So, how we carry out our field checks. Determination, the control method was very important for us. We had to use right method in the right place to get the right results.
Yeah.
We have determined 3 methods that can be used in the field controls. The first one is eye control. The first one is eye control. We prefer this method in areas where floor site is low and field production is not dense. On the right, you can see an example about this. Another method we prefer in field checks is the measurement method with laser meters. In order to use this method, the floor height must be low again, and with this method, we achieved interdisciplinary coordination by comparing the measurements produced on the model and with the field measurements. You can also see an example on the left. Now, I will mention about our third method. The area you see on the right is the departure level of terminal building. Floor height is about 27 meters. In this area, we had to check the 34 kilometer fire protection pipes and 17 kilometer storm water pipes, which located with roof steels. However, we could not use the other two methods that I mentioned before because the floor level is too high here. So, therefore, we prefer the robotic total station method. As you know, with total station, you can measure angles, create coordinates, and then you can apply these coordinates where you want. This is the traditional method, but here there is one difference. We use the total station with BIM. This is the workflow of BIM with robotic total station. With this sequence, we have checked all mechanical systems that we had to check and manage the quality control process, and finally achieved interdisciplinary coordination with this equipment. Another reason why we choose robotic total station method is project errors that I mentioned before. Here on the left, you can see the digital clashes of mechanical systems. The digital clashes were evaluated in 3D with BIM and largely eliminated in digital environment. To ensure with total stations, to measure with total station, we start site measurements. On the right, you can see our control points. It is the most important step for locate total station on site. After this, we create digital control points.
Yeah, I think you can.
Okay, and here you can see our digital control points. They are all created by Autodesk point layout. I will show you an example for your understand that how we measure that mechanical systems with robotic total station now. Here on the left, you can see a screenshot from iPad. You can also see the total station on the field. Right about there, but the blue pipe you have seen shows the location of the storm water pipes in our model, and the red point on the left, and the red point you have seen shows the location of this pipe in drill. After the defected step, we have created a digital report about this issue, and also you can see the site report. There is an example of measurement report. In detailed parts, we fill the location of defects and specify which disciplines are affected, and also in attachment parts we added site photos and measurement results. After we have created the BIM site report, we published it to our another iPad users. And finally, this paper, there is a paper I would like to show you. This article shows us the time and cost saving with BIM in Istanbul Airport. With BIM, we saved more than 16 million man days and more than 835 million euro cost. That is equal 5% of the total budget of Istanbul Airport project. Thanks for your listening. Now we can take your questions if you have.
Thank you all.
Yeah. Anyone have any questions regarding the presentation or regarding the project?
Thank you very much. It was a very, very good presentation. I'm very curious. When you embarked on this project, you were doing a lot of first-time things. What did you use as some case studies during your learning process to come up with your BIM execution plan, your federation strategy, and all of these things? Because you must have had some examples to work from. What were your references?
Mm-hmm. Okay, so I can answer this question. So if you want to add something, you can add.
Okay.
When we have started this project, actually we had the BIM team consist of 5 people, and our BIM director and manager were already qualified with the BIM implementation, BIM coordination. So they already came and formed the team, BIM team, in here with their own experiences with the previous projects. However, I can say that this amount of coordination was never, I think, maybe for no one in the project, was never experienced before. So we had faced many problems, engineering problems, problems caused by the tight schedule we have faced, but we have overcome with as I have mentioned in the presentation, with a very strict management and with a very tight and structured plan that we have deployed in here. So I can say that yeah, we didn't have a specific reference, but we have referred to the standards, the international standards, especially at those times. There were no international standard, as you may know. There were British standards. We have also referred to them when writing our BIM execution plan.
Thank you.
Thank you.
So it seems like Abu Sunday is raising his hand. Do you have a question?
Hello, I have a question.
Yes, please go on.
Yeah, sure.
My name is Abu Sunday from Nigeria. At the course of your presentation, I discovered that you display some satellite imagery in the course of your job. So I want to ask, at the course of your job, do you make use of any of GIS tools as a tool for this your BIM project? And if yes, at what stage it is required for us to use GIS tools in integrating BIM and GIS together in the terms of maybe BIM implementation in a large project like this?
GIS tool'larıyla ilgili istersen sen cevap ver. Neler kullandık? Do you mean the total station part that we have used in the construction site engineering checks by telling GIS?
Actually, about GIS, they just use.
I just want to.
There's a voice connection problem, I think.
But I can say about the GIS, we only use infrared for transfer during the oral process, but that's all. We have measurement methods about the actually related with some field works about the geometric engineering disciplines under, but
yeah.
related to GIS, we just only use infraworks.
Yeah.
And for airport.
Is this answers your question?
By the way, we can't hear you.
Yeah.
You say?
We cannot hear you. I think multiple people have their microphone on, so we cannot clearly hear you. If others can mute their microphones, then I think we can better hear you. Okay. Anyone has another question?
Hello. Do you hear me?
Yeah.
My name is Abdul. Thank you very much for this presentation. This is one of the projects.
Thank you for listening.
Do you hear me, guys?
Yeah, we can hear you.
Okay, so I will start over. My name is Abdul. I'm from Senegal. Currently, I'm working in the United States as a BIM as-built coordinator in one of the projects which is similar to this one, the Salt Lake City Airport project. So I have a couple of questions here, and through your presentation, I saw many information that are related to as-built. So my first question here is, what do you submit as as-built documentation? What is the final submission? That is the first question. And the second question.
Can you please repeat and what do you mean by the final submission? Do you mean the BIM model or do you mean other handover documents?
What I mean by the as-built submittal is, submission is at the end of the project, you guys have to submit, from what I'm guessing, you have to submit the 3D as-built completion punch list and the 2D as-built drawings. So do you put them together as one package and submit them to the owner, or do you, or what do you submit? What do you call as-built final submission?
Okay, I get it.
That was the first question. And the second question is related to the BIM site observation reports, which is a little bit related to the issues. I saw in your presentation you were showing the cable tray, which is not routed to the same direction as in the model, which is some kind of deviation or something like that. So, and you guys mentioned it very well as the first, you have guys two methods. I guess this first one is the site check report, which is the most efficient one, because that require to go to the site and see by yourself what is installed, if that match exactly what is in the model, yes or no. So, but in that case, if you guys find something that is, yes, this part, if you find guys something in the field which is not matching exactly what is model, for example, how do you handle those issues? Do you ask subs to change the installation, or do you go to fix the model?
Okay, I get the question.
Yes, those are my two questions.
Okay, thank you so much, Abdul, for listening and bearing with us and for your questions. I have you had very important questions to ask. So I can answer the first questions and you can read the second, I think. Actually, I can say that the ownership of the BIM model is at the airports operation teams themselves. So on the 3D model. So we didn't submit 3D model to the owner of the project. There is the government, and they did not require the 3D BIM model. So it was not required in the initial contract, but the management of the airport has decided that we'll do BIM in here, and we will handle the construction in BIM environment, and we will be fully using BIM at the operational phase. So the handover was done internally. The approach of as-built modeling, I think it partly answers your second question. The approach of ours is fully coordinating BIM model first and delivering them to site, and having site installation most accuracy. So we have nearly 95% accurate as-built BIM model that we have done with the coordination. Of course, there are defects on site. There are some miscoordination on site, because you cannot 100% construct the same as in the drawings or in BIM model, but they were all recorded in the BIM 360 environment, and if they cannot be reinstalled on site, we haven't put in them in the BIM model. This is not the case that we have faced all the time. The case we faced most of the time is we have correct site installation according to the BIM model. Because when we didn't do that, it affects other installations that will be happening in the later phases of construction. So we didn't have any luxury to not following the BIM model, actually. Because there were very little time, there were very tough job sequences. So if you construct one system wrong on site, it will affect another and another. So our site team has provided support on site to apply BIM model as the coordinated. So I think this answers your question. For the second one, I think Tolga can say something. He asked that the BIM site observation, in the BIM site observation report, he asked that you have corrected the site installation according to the BIM model. He was asking about this is the old time case, or you updating the BIM model according to the site installation.
Okay, actually Ahmet answered that. For the better coordination, it should be like our model. Otherwise, if you, for example, if you install your equipment, your manufacturer wrong, or not like our model, it should be the program for other disciplines. For example, you can see the here they install electrical cable tray and also support here, but they don't know where it should be. There is a wall here. We check from iPads. When we check, we see a wall here. We measure distance between the wall to wall, and we can understand the side checks. It is wrong. It not should be, because the wall must be there. So we report this case and we actually immediately call other teams about the situation, and then they fix it like our model, because it should be otherwise there will be a problem for us for everything.
Thank you. Regarding your first question, I have to add that you have asked also about the 2D built drawings. So what we have done in here, provide the subcontractors who are responsible for producing the shop drawings and the as-built drawings according to their contract. We have submitted them the fully coordinated 0/3D BIM models and required from them to produce shop drawings in the first hand, fully compliant with the BIM model. So we had a system in our team that checks all the shop drawings according to the BIM model, if they are compliant or not. And the approval process also was handled by our team. If it's not compliant with the BIM model, then the shop drawing is rejected and they're not uploaded in the iPads and they're not delivered to the construction site. For the as-built drawings, contractors also step by step updated their shop drawings into the as-built drawings, looking at the site inspection reports. At site inspection reports attachments, which all held on BIM 360 also digitally, there were drawings attached, fully approved drawings, and if there are any changes in the routings of the system, they were marked up at the attachments of drawings, and as-built drawings were produced like that. So I can say that as-built BIM models were handed over at the very end of the construction phase, and the 3D as-built drawings were handed over step by step when the subcontractor has in their planned schedule.
Thank you very much, guys, for your answers. So this is some kind of, I can say, is a little bit similar than what we do here, but not exactly the same. You guys putting a lot of efforts of completing all of this section step by step. And the reason why I ask that question, for example, specifically for the first question, is the way we're doing it here is we are submitting what we call bid package. So what I mean by bid package is, for example, if we're talking about everything that is underground utilities, we are specifically call it bid package. For example, 3 is storm drain, plumbing, piping, everything that is related to digging. So in that case, we submit that one, and we submit 2D drawings and 3D as well, completion list. So this is some kind of requirement from the owner. So here, the owner here is the Salt Lake City airport. So that kind of route, or that kind of like method, or that kind of way to submit the 2D drawings and as-built drawings is very important, because
exactly.
Yeah, it's very important. So that's why there are many requirements, and sometimes it depends of the contracts basically. So those requirements are specified and designed by the owner. So thank you very much, you guys, for taking the time and answering those questions.
Yeah, thank you also.
Thank you. Thank you.
Okay, so we have other questions in the chat.
Okay.
Christopher is asking, okay, before Christopher Mbabu is asking to say what procurement type was the project? Did you use integrated project delivery procurement type to harness collaboration?
Can you repeat again, please?
There was a question in the chat that asks what procurement type is this project? Have you used integrated project delivery procurement type to harness collaboration?
Okay, just let me check. in the chat. I see.
The new chat button.
Okay, I think the question is about the procurement. If we have used any integrated procurement methodology or not. Yes.
Yes, and there were other questions above and beneath it, so please just respond to everything in the chat.
Okay, I can say that for the procurement is a very wide range operation. So a dedicated department was responsible for the procurements in here. But what we have enabled is, I think, the digital fabrication. I can say about the procurements. The 3D coordinated BIM model was handled to the third-party providers for them to produce mainly the steel structures in their factory and facade elements. So these are the main digital fabrication parts that has been handled BIM-based and integrated with BIM-based. But other than this, this is a very wide range operation. But I'm actually not sure if they have used any integrated solution for the entire project operations. I can say this. But I can also mention that through the model, we have periodically take the quantity information to the technical offices of the departments. So they have managed their procurement, their invoices, their bills. They have checked all of those according to the quantities taken from the BIM model.
Okay, thank you very much. There are still a couple of questions you have here. I think the first question came from Victoria. She asked, how did you handle tracking changes to the selected BIM model? There are any challenges regarding version control?
Can you hear?
Yeah. No.
I think your microphone voice is very, very low. Moses, if you can hear Onyem, can you read that question again?
Is that possible to write? Chat?
Yes.
Yeah, if you can write through the chat, we can better see the question, I think.
Yeah.
Hello.
Okay, so another questions in the chat asked that who initiated the use of BIM in the project? Was it the client, the general contractor, the lead designer, or a subcontractor? And then what were your greatest challenges when implementing BIM on this project? And also, how long did it take to complete CD phase? Did the implementation of BIM pay off in that phase? Was it considerably shorter?
Mm-hmm. Yeah. At the beginning of the presentation, we have briefly talked about the challenges. So I will tell you about how much time did it take to implement the BIM in the airport and the construction phases. However, I can say that overcoming these challenges, the most important thing in here, one of them is top management support. So if you don't have the top management support requirements, then you will likely be struggling implementing building informed modeling entire the project. The second one is changing the mindset of the people. Usually are used to work in conventional methods. So this can be achieved by giving trainings and continuous support to them and continuously telling them why we have to implement this. So these two aspects were the main reasons why we could overcome the main challenges. When we come to the timing, how much time it did implement, it took only 3 months to utilize the BIM team and BIM environment and assigning the key personnel to the departments. It took approximately 3 months, and it didn't finish at that point. It was a continuous process that we always had new subcontractors involved, new designers involved, and continuously we had kickoff meetings with them, telling them about how we implement BIM in here, sharing the BIM execution plan, and tracking all time is the key element in BIM implementation. With the correct team you have, you can connect all the people with, for example, very small team. You can have a very large impact because with the right tools BIM has providing us, you are connecting lots of people, lots of architects, engineers to work efficiently for the project. So you don't have to be tens of people to manage BIM, but you have to be logical at core and get the right information to produce the right product and deliver the products on site on time. This is the main thing I can say during the BIM implementation.
And also I think the BIM implementation was a challenge for us. It is true, but they understand better after we create our site reports. They really understand our methodology is better than the classical methods, and our solutions are faster and cheaper than. So in the beginning, it was a challenge.
And one more aspect additionally, we had the contracts between the general contractor and the subcontractors. The most of them includes the clauses of delivering the drawings in compliance with the BIM model. So when we have this in hand, we have the power as the contractual side. This is also very important because when a subcontractor says that we cannot do that, we show them the contract because initially compliance with the BIM model and producing in compliance with BIM model was included in their contract.
Okay. Yeah. So Donatus was asking that what was the team structure? Was it an all in-house design team or you had independent consultants assembled for the project?
Can you please repeat again? We couldn't understand.
The question is that what was the team structure for this project? Was it an all in-house design team or independent consultants assembled for the project?
Okay, so it depends on the discipline and it depends on the asset in the airport. So we had assets designed in-house. We had designs outsourced. It depends on the discipline. For example, the conceptual design was done by a foreign designer. And the developed design was handled with some other subcontractors outsourced. However, our design team is also involved in the design in terms of architectural. In terms of mechanical and electrical, it was all outsourced and designed by subcontractors. So mainly general contractor here, we had the monitoring and approval process in here. So mainly designed and fabricated by the subcontractors.
Okay, would like to inform everyone that we can see a lot of questions coming in. We may not be able to respond to them all. You can please send us your questions through our email, info@bimafrica.org, and we'll respond to them from the authors. So a question here says, how did you handle tracking changes to the federated BIM model? Were there any challenges regarding version control?
Okay, first of all, since the project was design and construction at the same time, the handling of the design changes was a very, very important aspect, because the construction is happening on site, where you already have a coordinated BIM model. Suddenly a new design comes and submitted for an approval. So this may cause a lot of trouble for the project's sake. So what we have done is reviewing the design changes, and with the help of our site team, if the design change caused a huge impact on the construction sequence and the schedule, we just reject the design change in terms of any discipline. So, but if the design change is necessary and in an engineering perspective, it provides more maybe cost efficiency in terms of the equipment numbers or the routings of the systems. So we were reviewing those changes, and if they are not constructed on site already, we were updating our federated BIM model, and for that specific area, always publishing to the and letting know the subcontractors of that change. And by the iPads and mobile BIM, those changes were immediately published to site through BIM 360 Glue and Field app. So everyone knows what have changed and where is the design change happens. So, but this have been structured on a RFI and design change request workflows. So nothing just happens like someone wants change and it just only happens. So it follows a workflow that comes with many approvals from many departments, but all of them was happening on a digital platform and as fast as possible, because we didn't have the luxury to wait for a design to be approved. The first day was immediately organizing a workshop and checking through the BIM model and having the information from if the site job is done or not. This is the first question. So the second one is it affects another coordination. It causes any clashes in the model. So if those issues can be solved, then the changes were integrated in the model, we can say.
Okay, so the last question.
Yeah.
From my understanding of a digital twin, there is both static data, that is from the record model, and dynamic data from the facility in real time, and some communications with sensors. Could you shed more light on how you intend to convert the record, which is a BIM model, to the digital twin?
Yeah, I mean, is that a question of how we converted Revit to another file types? I didn't get it.
Okay, maybe you could check the chat. I also don't get the question.
Yeah, okay. But the thing is, we cannot see the message in chat. I don't know why. I'm checking the recents, but contacts, no. Maybe it's better if you can.
Anyway, yes,
repeat.
we would send all of the questions that we could not attend to you, and then we would get back to everyone. Thank you very much for the time. We really do appreciate it, and we're looking forward to more interactions with IGA. We hope that we are sure that the audience had a very insightful time learning from a real-time project, and we believe that everyone is inspired to kickstart in their own project also.
Yeah, correct. If you guys have any questions regarding our presentation on our project, you can always contact with BIM Africa and forward us. Also, we will be able to answer your questions. So, also we were very pleased to have this webinar. Thank you again for bearing with us. Thank you to BIM Africa also and BIM for Turkey for utilizing this webinar.
Thank you all.
Yes, thank you very much. You have a nice.
Thank you.
Thank you very much, guys.
Thank you guys. Bye-bye.
Bye-bye.
Bye.